In relation to one of the problems that I was asked about, let's just say you got a disk here with a charge of charge density 5 microcoulombs per square meter. Okay? And you got another disk over here with a density of -3 microcoulombs per square meter. Okay? Now you can figure out the electric field due to this disk, right? Let's say at a point directly above the axis, okay? And you can figure out the electric field of this disk, say at a point above the axis, because you know how to do that. It's an easy interval. Okay?
Mm-hmm.
Make sense? Okay. So if I wanted the field at any other point, well, there'd be a field due to these things, okay? And if you take this into 3 dimensions with a charge distribution inside of each thing, and each of these is a sphere, you can actually apply Gauss's law to each one. Okay? So this creates a field, not just on the axis, but everywhere. It's just harder to calculate off the axis, okay? Probably have to do some approximations. And this one also. Well, what if I take this one and move it here? Then effectively, what's my charge density within this thing now? Within this circle, it's going to be 2 microcoulombs per square meter, right? Because, you know, if the 5 and the -3 add up to 2, right? Well, what if this was -5 microcoulombs per square meter?
Would the charge not diffuse? Or?
Well, the charge is on something that prevents that.
Okay.
Okay, it's on some kind of an insulator, but a thin insulator. Okay? And yes, it would tend to diffuse. So that's a good thought. But now we're assuming it doesn't. Okay? Because what we're doing now is we're now modeling with this and this, putting this here, we're modeling a disk with a hole in a charge of 5 microcoulombs per square meter everywhere except on that hole. Okay? And the electric field will be the sum of the 2 electric fields that would be due to a -5 microcoulomb per square meter here and a 5 microcoulomb per square meter through the whole disk, right? Okay? And when the problem that you asked about said use superposition, that made it entirely obvious you had to do this. So try again.